My name is Didier, and thanks a lot for joining this developer community Munch and Learn. I looked on that this is the 31st seminar we've been running under that program. We started in January 21. Today, the topic for discussion is secure GenAI adoption for all. And the topic seemed to be quite a popular one because we've broken our record in terms of registration. So thank you very much. We have three speakers today, Glenn, Tom, and Zad. And before I hand over to Tom, I would like to go through a couple of slides. Some of you might already know that. I'm sorry, this is a repeat, but the HP Developer Community Program has this Munch and Learn series that you are attending today. And these are thought leadership sessions, product and vendor agnostic, trying to be at least, delivered by our best speakers. We have this session today, and we have already a planned session for the March Munch and Learn on the 20th. You can already take note of that. It's going to be another AI session on more like on the resilience. And we'll have, again, three speakers, and they'll be from the HP Labs. So that should be a very interesting session as well. We also run another program called the Meetups. And the meetups are a little more in-depth into a particular technology, open source or not open source, but in general, we try to be. We have a session on February 28th on Aruba Central, done by our colleagues from the Aruba team. And we'll look through the APIs. We have a session planned for March 27, that's going to be. And this is very interesting because this is our team delivering the session. So I'm very proud of that. We're going to be talking about the GreenLake APIs. And then we have an April sessions, which will be delivered by our colleagues from the storage team on the DSCC, or the Data Services Cluster API. So that's kind of the program for the coming months for both Meetup and Munch and Learn. We have an additional way you can skill up using the HP Developer Community, and this is called the Workshops on Demand. We have a catalog of workshops available 24/7. We leverage Jupyter Notebook to deliver, and we have a catalog of 30 workshops right now. It's a good way to learn technology. We have workshops on learning Python, Rust, learning what an API is, learning Kubernetes, Docker, and some other technology like that. Feel free to give it a try and provide feedback. We have a survey at the end of that if you think we're missing something there. This is a community, so we need help with amplification and contribution for sure. If you enjoy these talks, feel free to join again, of course, but also feel free to forward the invitation to others. This is open to anyone, customer, partners, students. So we'll be happy to share these talks with anybody really. We also run a monthly newsletter. You can sign up from our website, developer.hp.com, I think at the bottom of every page. And feel free to invite other people to join. This is the best way to get notified of upcoming talks and maybe blogs that might be interesting and other things that we do during the month. We have a Slack. It's a dedicated Slack, external. Again, we accept customers and partners there. You can join and help other people, or you can ask questions there. Feel free to sign up for that Slack. We have an X Twitter account. If you're more on the Twitter side, you can follow that as well. If you are a subject matter expert on a particular technology, we'd like to hear from you. Maybe you can help us with blogs. There's a lot of blogs on our website, and if you take a look at the blog section, know that this is half of the traffic going to the site. So it's a popular way to learn. If you would like to write a blog, it's possible. We use an open source content management system, so it's very easy to contribute. You basically need to write a couple of markdown lines, or you can use a rich text format as well. And you need to have a GitHub account, so nothing really exceptional there. So you can write a blog, or you can deliver a meetup maybe in an upcoming month. You can help us in some events. We have events that we go to, for example, HP Discover, and in a certain case, we're looking for help to man the Hack Shack. And then if you also would like to help with workshop on demand, this is an option. If you think there's a gap and you can help with one of these, we have a framework, we have an environment. It's pretty easy to add new workshop to our catalog, and then people can use it to learn new stuff, or you can even use it to teach people new stuff. So think about that and reach out to us. So that's all our touch points, if you want, whether this is Slack. We also have an internal Slack for the HP folks in the room here. We have our newsletter. We have an email, of course. We have the Twitter handle. We have a Yammer group for partners. This is a direct link to our workshops on demand. You have all these links into the QR code right there if you want to scan that. For the rest, this is going to be with Tom next, with the secure GenAI adoption for all. Thank you, everyone, and let's get on to the real content of the session. Thank you very much.
Thanks. While Didier is bringing up a poll, we have just two simple questions as we kick off this next version of Munch and Learn. My name is Tom Phelan. I'm accompanied today by Glenn Bowden and Saad Zahir. As Didier said, we are all members of the HPE, Office of the CTO, Technical Incubation or Innovation Office. I know it's a long term, but we've been exploring generative AI for the last year or so, and we're going to go and talk today about how you can use generative AI securely. Before we do that, though, please spend a few moments here with the poll. Tell us, hey, have you ever tried to use generative AI, either at HP or in your enterprise? And then if you can't, or if you haven't, why haven't you been able to do it?
Very nice. So we have a good chunk of people that have replied already, almost 60%. So we're going to maybe end the poll and spend some time on the result if you want, Tom.
Yep, sure. This is great. We have 330 or so people on this call today, so we'll have a good cross-section of users. Let me see. There we go, the results. Okay, so maybe 1/3 of people the audience have been able to use generative AI. I actually liked it. That's higher than I thought it might be. That means we have people out there using generative AI in their workplace. And for barriers, this is evenly spread. This is really interesting. I like that last one. I never tried it. About 0%. Okay, good. So questions about the trust for models, risks of leaking data, don't know where to start. So, and then the IT security issues themselves as, company policy. This is good. We'll address these limitations or risks going forward. In that fashion, Glenn, if you could just advance it to the next slide, and we'll begin here. Hey, the whole world. Okay, we're gonna build out the build. Okay, so prior to November 2022, we were using artificial intelligence and machine learning and even LLMs. However, at that time, most of the use cases were enterprise driven. They were computer vision, where we had manufacturing lines and we were using AI to take pictures of products as they were being developed, and we did automatic QA. And so what we were using a relatively small, if you will, LLMs like GPT-3 with 175 million parameters. And we had an API, which we go back and forth and do text completion and things like that. But these LLMs tended to be use case specific. As we can see on the graph on the left, we started in 2018 with Elmo, with a rather small LLM of under 100 million parameters, all the way up to this Megatron, 500 billion parameters. But they were mostly, like I said, limited to specific use cases trained with specific data, and required an API that engineers had to program to in order to use. And Glenn, let's go to the next slide. But then in 2022, and in November, we had the introduction by OpenAI of ChatGPT. This was an interface which allowed, and I'll just say the common person, to interact with an LLM without having to program, without having to use an API. There was just this chat interface. You'd type in a text line, it would respond to you. And what we had is we had the introduction of multimodal LLMs that could take in both. Thank you, Glenn, for moving it. Both text and images and respond back with a text solution. And then these things, you could ask it questions and you could clarify, so you could refine the solution or the response that you got back from LLM. And we had the introduction of extremely powerful next generations LLM like OpenAI's Chat GPT-4. This had 1.75 trillion parameters. So a huge advance in the amount of data that was being used to train these LLMs. And Glenn, let's just build it out here. So we had Google's Bard and Anthropic's Claude 2. And this prompted people like Microsoft to say a new day has dawned with respect to the use of AI and particularly LLMs, and we have to move fast. So let's go to the next slide here. So there were immediate use cases. As I said, prior to November 2022, there were specific enterprise use cases for LLMs. Well, with these new LLMs like GPT-4, they came out of the box well trained with historical information, and we could easily start to do queries. So this was fantastic for college students. The professor asks, hey, write me an article or a blog or a paper on who William Shakespeare is. You could just type that into Chat GPT. Since it had a prompt interface, it would query the LLM for us, and it would respond with something that made sense about who William Shakespeare was. And if you wanted to translate it, what we're showing here is you could translate it into German. Say, okay, I have this in English. Now translate my paper into German for me. And then a click of a button, it would do that. And it was also trained with current events. So we're not just talking historical data, like a historical figure like William Shakespeare, but we can ask a question about the US elections in 2020. It had been trained with news articles on the internet on how to respond. And so it would give us something intelligent about the US elections in 2020. And even more, it could extrapolate. Let's just go to the next build out there. You could actually ask it for an opinion. So, hey, tell me the best Harry Potter movie for some definition of best. Okay, each person's going to have a different definition, but the LLM itself could almost provide a human-like interaction where it could seem to provide an opinion. These were huge immediate values in academia, in legal, in any sort of written or printed media. This was a huge change, and you had to use it because your fellow students were using it, or your fellow or your competition in the industry was using this technology, so you had to get on board. Glenn, let's go to the next slide. This led to a huge race because you didn't want to be left behind. You had these powerful tools, Chat GPT, that allowed us to use LLMs without programming an API. And we had these really leaps forward in complexity for these LLMs that could be used immediately out of the box. This was the true democratization of LLMs and generative AI. You could use it without being a programmer or a subject matter expert. So public got exposure to this. We started seeing use cases. You don't want to be left behind. It's a train on the tracks. So Glenn, let's go to the next step. This sounds fantastic, but we ran into reality. Okay, there were famous examples of data that proprietary data that accidentally got exposed by an unintended user of a publicly hosted LLM. So, if I'm sitting inside HPE and I type a query, but I actually attach some additional information to my prompt, to my query, it accidentally got uploaded and included in the LLM itself because the LLM learns from the prompts that are being submitted to it. And then that data actually got released to the wild and they lost control of that intellectual property. In addition, there were concerns around security. I'm getting information back. How do I protect that if there's personal identification information or even ethical information? How do I know whether I am ethically using the information that's coming back from the LLM? And in addition, there's a thing called hallucination, where you get what sounds like a completely valid response from an LLM, but it's completely wrong. It's not true. So there were examples of law firms who had asked the LLM about particular law cases, and because it didn't know the answer, it just made one up. And it sounded completely reasonable, but in fact, it was factually false. These are all issues that limited or basically put the brakes on to this democratization of generative AI. That's when companies like HPE stepped in and said, hold on. We cannot allow our employees to use generative AI for business purposes until we get a better handle on the security and control and the usage of generative AI to make sure that it is ethical, it's legal, and so forth. So Glenn, let's go to the next slide. And these are the areas. So because of the velocity of change and the velocity of advancement in this area, we have to make sure that we approach this area with security in mind, privacy, not only for privacy for data which already may be in the LLM, but also data that may be provided by the prompter, by the individual using the chat interface to the LLM. We have to make sure we use it ethically to not discriminate against certain people or groups. And then we want to make sure that we accurately identify what the limits of the LLM itself. So when we reach these areas of hallucination where the LLM is returning something to us, but it's not true. So this is how we need to explore. And so the remainder of this talk and this lunch and learn today is how are we going to provide these protections to the users, both HPE internal users and our HPE customers. So Glenn, let's go to the next slide, and I'll turn it over to you to describe how we're going to use generative AI securely for enterprises.
All right, thanks, Tom. And you'll notice let me very quickly skip back a slide. You'll notice from Tom was talking about hallucination. The image is a very good example of this. Factually, it's exactly what's asked for, but you can see the cars are actually going down the track alongside the train, which hopefully in reality isn't how that occurs. So this is a good example of where GenAI does exactly what it's been asked to do, produces exactly the thing that you prompted it for, but it's complete garbage. So let's have a look at the kind of various layers that generative AI are used with an organization. How can you engage with generative AI? We see it as a kind of a triangle, and I'll show you the reverse of this in a minute as to why we're thinking in this way. The public generally and sort of the mass users of generative AI are really hitting that consumption layer. So they're going to the prompts on OpenAI or Azure OpenAI, wherever it may be. They're typing in their prompts. They're getting back their information, whether it's images, whether it's they're generating text, whether they're getting answers to questions. That's all at the consumption layer. They're not doing anything else there apart from just providing the question and some context in the question that they're writing. We then move up into orchestration. So orchestration is actually where most businesses are starting to leverage generative AI. Orchestration involves the ability to add more context, sometimes automatically, to the questions that you're asking. So orchestration could be the use of RAG, for example, which is retrieval augmented generation. So that's taking input from documents like PDF documents or documentation you have online about a particular product and seeding the model with that by using things like vectorization in a database. You then use that as a context for the question that you're asking, and therefore the answers you get back are augmented with the data that you provided. So it knows what the context of the question you're asking and can provide much more specific and hopefully accurate information. Again, hopefully accurate. There are still hallucination pieces in there. So that's that orchestration layer. Again, a little bit harder to do than consumption, a little bit more work is needed, but it's still easy enough that most people can manage that. And there are many tools now that are beginning to have orchestration as part of their tooling anyway, so that it can be still a low-code or no-code approach to getting that orchestration, that RAG piece in there. It's also the exposure of APIs. So consumption is really just about primarily using that interface, the user interface, where you'll type in your questions and you'll get the answers back in the same interface. Orchestration now is starting to use APIs to have programmatic access to be able to ask those questions, and then also consume those responses as well. So you're not necessarily having only users and people talking to the model at that point, but also having services interacting with the model too. As we move up the stack, we get into fine tuning. Now, this is the ability to actually influence the model itself. So not just influence the questions and the context in which those questions are being asked, but provide data into that model. So fine tuning, there's a couple of ways of doing that. LoRa is probably the most common one at the moment, where you're affecting, as you may know, the generative AI model is multiple layers. So in fact, there's millions of layers because you have billions of parameters in there. Fine tuning is really affecting, as an onion skin, the first one or two layers of that model. So you're adding the context on the outside of the model, but you're still retaining all of the rest of the data and the information that's in the kind of base model that you're using. Fine tuning is a way of more rapidly getting data into that model because you're not going through that same very expensive tuning process or training process that the whole model will need to do. So you're doing some manipulation of those edge layers. When you get into retraining, that's really providing a whole new data set or portions of a data set or an augmented data set to the model and going through a much more aggressive retraining of that model. So it could be deeper into the model that your data is progressing. This means that some of the context within the model itself can be a little more refined in terms of the actual use case you're trying to do. However, it's quite an expensive operation. We'll see that in a second. And then at the top of the stack, there's the neural network design. So this is building those models from scratch. This is architecting the model, writing the code for the model, building the actual data training sets out of it, doing all of the data grooming and everything else that needs to be done, and creating that model. So that's a very niche piece of work. And you can see at the bottom, we've got sort of the producers, which are the training and the fine tuning, and then the consumers, which are the prompt engineering inference and the fine tuning piece at the bottom. Now, as we're looking at sort of how we're using this, it's very difficult. You look at the processing controls on the left-hand side. It's actually quite difficult to police what's happening on those lower layers because they are so broad. And so that is where a lot of focus has been at the moment, and we'll see this as we move through the presentation, around providing governance and security and guardrails in this space. So if we flip the triangle upside down, the same boxes refer to the same thing. So at the bottom, we still have consumption. At the top, we have that neural network training. What we're reflecting here is, at the top of the triangle, it really is a niche. It's extremely expensive to do. We're talking about large GPU systems, or by large, we're talking thousands of nodes, possibly tens of thousands of GPUs within that can take weeks to train a model. These models are costing multiple tens or hundreds of millions of dollars to train, depending on their size and depending on the cluster that's running them. So you can see this isn't for everybody, certainly. And you don't want to be doing that multiple times either, because it's an incredibly expensive process to be able to build. As we move down, you still have those large GPU clusters. They can be a little bit smaller and a little bit more refined, and the process doesn't take quite so long. So you're then doing that retraining piece. So again, it's still fairly deep in terms of how you're affecting the model, and you need some data science skills and some tooling to be able to do that, but it's much more accessible than that training the model from scratch piece. Then as we move down the stack, you can see the trend here. It becomes slightly more efficient, slightly more affordable, and slightly less skills are needed to be able to do it, all the way down to the bottom where it's extremely accessible, it's very democratized, and pretty much anybody can interact with it. So when we're looking at enterprises, there's not really that much value in the bottom layer, other than just being able to access tools that already exist. You're not going to differentiate yourself. The easiest way of getting differentiation through the use of generative AI is really through that orchestration layer, the cloud instances, tools, and additional data piece, as well as then that refinement layer, and all the way up possibly into retraining. But we're kind of sitting between layers 4, 3, and a little bit up into 2. And you can see as well there's the dollar associations and obviously the power associated with it as well. So if you want to be environmental, we certainly don't want to be training these models on a daily or weekly basis. So if we take that triangle again and look at where we're focusing. So we're looking at the kind of orchestration piece here. So it says HP opportunity. This is where enterprises are focusing. So this is where we see we can make an impact. From an orchestration perspective, the type of outcomes you'll be driving with an orchestration layer are things like customer experience enhancement. You want to be able to have the customer ask questions about products or support or services that you have. Some code generation. Again, there's some of that available in the consumption piece, but actually it's most useful when you augment it or expose that model to some of your own code as well, so that your same standards can be followed, your private libraries can be recommended, those sorts of things. That can happen in that orchestration space as well. And then just general employee productivity, where an employee can ask questions about documents relating to the enterprise or the organization, not just ask general knowledge questions, because that's not so useful to the employee. The functionality you're looking for are things like being able to access, manage, and metering access to models. Models can be expensive. Even in inference, there's a cost associated with actually running that inference. Depending on the size of the model, depending on the time it takes to infer, and the amount of data or tokens involved in generating that answer, including in the request, there's costs associated. So you want to be able to make sure only the right people have access to the right models and they have a budget that they can spend against those models. You're then building inference pipelines. So the pipeline is really something that will include things like RAG. So it's not just you and the model interacting. You're going through a set of tools. Now, that could be complicated. You could have one model talking to another model, talking to a third model, even passing responses between them, so it acts like a conversation. Or you could be having things like, as I said, RAG in there, or multiple RAG in there if you're getting many different data sources. So it's a lot of different sort of chain of thought and chain of reasoning where you're building up those answers. And we have automation and configurations in there called agents, which can set things like the persona or the response tone that you're going to get from those models as well. So all of that needs to be packaged up. We've already talked about RAG, so I won't focus on that too much. But again, you've got the user has raw access to the data, which means they've got the potential to pass that same raw access onto the model they're accessing. So we need to start looking at things like content firewalls and AI guardrails. And we'll go into a lot more detail in that. And Sad will talk about some specific implementations we've been testing. And as I said, programmatic access. This is where services start acting with the generative AI piece. As with AI and machine learning, when it first sort of became popular about 10, 15 years ago, there's a need for, as you're getting good answers from these things, to be able to think only at the speed of a human being and respond only at the speed of a human being is detrimental. You need to be able to often respond at programmatic speed. So a service that can respond in milliseconds or microseconds, depending on the answer it's getting. This is as you start moving into things like AI ops, which takes us up to fine tuning. So fine tuning, as I mentioned, is augmenting that couple of layers of the model with more specific data about what you're trying to do. So the model has more awareness rather than just a request and response paradigm. With this, we're starting to see things like AIOps become much more possible, much more feasible, where we're training it on previous log or previous telemetry. And so the system's starting to get an understanding of how to predict when something might be going wrong, and even how to predict things like root cause. And there's a lot of research going on in this space at the moment, including some work we're doing. If you're doing that sort of thing, then that programmatic access is absolutely critical, because it's not just about telling a user, it's about being able to respond in some way. So in order to feed the system in the first place that an event has occurred, that's programmatic, and even to consume the knowledge and then render it in some format that's much more contextually sensitive for that user, again, programmatic access is needed. Again, as we go through fine tuning, we're looking at things like product design, asset management and tagging, things that are a lot more specific for that organization, that aren't just about the documentation it produces, but maybe more fundamental than that in terms of the content and the data that you need to feed into that system. So in order to do this, obviously there's tooling for fine tuning. You can just use new data and rerun models to fine tune that way. What you tend to find is there's a little bit of need of data science, so training some of the weight, tuning some of the weights, tuning some of the parameters of that model manually before you run that training job. To do that, you need things like experiment management. We have a product called Machine Learning Development Environment, or MLDE, which helps you with that sort of thing. So you can able to run multiple experiments and see which performs best before committing to that final training piece. What comes out of that is a model, obviously. So you need to be able to package and access control that new retrained model. So if it's got new data in it and is more specific, that may have different policy requirements than the base model on which it was trained. And so you need a mechanism to be able to do that. And again, as we've talked about the budget for these things, there's cost control and auditing. You need to be able to sit around that. Being able to fine tune means running fairly long running and expensive jobs. So the cost control is not just now around the inference, but it's around actually being able to execute that fine tuning job in the first place, and how many times you can do that and on what data. So these are some of the questions that we typically ask customers we're working with or ourselves as we're moving into these. And these are typical sort of frequently asked questions we get asked back as well. So the first thing is, and we saw on the poll at the beginning that knowing how to start is actually one of the sort of, I think it was about a quarter of the audience where we're not really knowing. So these questions may help with that, or may questions you have. Firstly, it's which model am I using? Which company do I go to? Am I using an open source one? Is it going to be publicly hosted? That kind of thing. And we'll have some guidance a little bit on how to make some of those choices. Is the model production ready, or is the application that's consuming the model production ready? And they're two different questions. The model could be considered production ready in the sense it's trained on the right data. The application may be asking questions with parameters that mean the model is going to hallucinate, and therefore it's not good for the use case you're trying to drive it to. So understanding what the use case is critical to be able to answer that question. Governance covers a couple of different things. So firstly, it's what can I do to actually train, retrain, refine, whatever it is you're going to do to the model initially? What context can I provide to that model? And am I using the data that I have in a way that's in line with any agreement I have around when I acquired that data? In most countries, Europe I know very well, and the US has similar governance or similar rules. When you gather data, you enter something called the Data Protection Act in the UK, for example. That Data Protection Act means at the time of collecting the data, you need to state what it's being used for, and you can only use it for that need. So do you have the right governance in place to be able to suddenly pull that data and inject it into a model for which didn't exist at the time you gathered the data? Now, many companies have got a little bit wiser and have very loosely defined usage of the data when they capture it. Many people have picked up on that and reject the T's and C's if you happen to read them. But that's the challenge we're getting into. Social media is a perfect example in this space. We all used our data with social media organizations for specific reasons, to interact with our friends and our family. But now they're training models on it that might be used for creative uses, including creating fiction or images and those sorts of things. And we're not necessarily sure that we want our data to be part of that piece. So the governance has changed. So we need to be able to say, not just what do we do about governance of the data we're using, but how do we use what comes out from that as well? And do we have the rights to use that? Tom spoke briefly very earlier on about ethics. Is it not just legal, but is it the right thing to do as well? Which use cases are ready? So GenAI isn't good for everything. As with machine learning when it first came out, whatever the question was, machine learning was the answer. The same is now true of generative AI. It's definitely the answer for every question that we have. It's extremely powerful. It's extremely useful. It's not always the best thing to use, though. There are maybe much cheaper, much more efficient, and much more traditional mechanisms that work at least as well, if not better, than generative AI in a lot of circumstances. So look for the use cases that really do benefit from generative AI. They're often creative use cases at the moment. We're seeing more deterministic use cases become better and better as the models get refinement and the broader scope hits us. And what do you need to get started? An idea. You need to know what it is you're trying to solve. You need the thing that you want to be impacted by the use of generative AI. That's always the first place to start, is what am I trying to solve? What problem am I trying to solve? And what data do I have that I'm legally and ethically okay to use to solve that? Once you have that, then there's a number of steps you can go through to actually start trying out your idea, starting with things like using public API endpoints. So ChatGPT is a good example that everyone's available of. Then moving up that pyramid to do some refinement, add the contextual pieces, possibly moving into retraining. But start with the basics first. Start with an open model that has no context to see, actually, if I ask this sort of question, what's the structure of the answer I'm getting back? Does it make sense to me? So we want to start talking about security, privacy, and governance, because that's really the barriers that we saw at the beginning in that poll specifically, and what we're hearing from our customers on a regular basis of what that challenge is. So OWASP is a security organization or an open organization that really looks at various different sort of security across multiple applications, and they've produced their top 10 for LLM applications. You can see here that they've got sort of, how many have we got here? 10, obviously, because it's the top 10. But they're very sort of functional. So they're looking at sort of theoretically what are the domains of problem. I'm not going to dwell on each of these. You can see there's a link to the paper that talks about these in a lot more detail at the bottom of the page. But this is the kind of formal version of what OWASP produced in terms of these are the risks. If we look at where we can attack GenAI, so not just looking at the kind of governance and data piece, but actually if I'm a bad actor, what opportunities do I have to influence this? So obviously there's something like a training time attack. That's where you're compromising that training data. You might be injecting bias into it. You could be just polluting that data in a poor way. We've seen examples of this with things like the Microsoft Tay chatbot that immediately went rogue and started, I think it was very sort of offensive to people, swearing, that kind of thing, just because of the data it had. And that wasn't necessarily an intentional pollution. That was training on data that wasn't filtered. And so it ended up in that way. But you can intentionally do that as well. There's then the inference time attack. So where your model is safe and you know the model is the one you have, you fingerprinted it, you have security around the model, you then start attacking the data that's coming back from the model. And there's a couple of ways of doing that. And we'll look in a little bit on where some of those sort of handles are that you can start tweaking that. But this is where the attacker is actually trying to either pollute the query on the way to the model, or it's trying to pollute the query as the model ejects it, so egresses it back towards the user. If you can control the inputs to the models, then whatever question gets asked, you can manipulate before the model actually provides the response. Or you can inject the response as it leaves the model and manipulate it that way. And then finally, the attack on the edge or client. So this is the thing that's actually asking the questions. So you can pollute that response and request long before it ever gets to the model. The model can be absolutely secure, but the client that's sending and receiving those responses might be getting or receiving bad information because you've compromised it there. So you can see there's multiple layers. Our tech advance team within the Office of the CTO have also been doing a lot of research into this area. This is their kind of list of security mitigations over an AI lifecycle. They've also done a lot of research on various players in this space. It's an incredibly dynamic space. We'll see that in a minute when Sad starts talking about some of the work that he's been doing. But you can see that there's, as you move through the model lifecycle, there's lots of different places that we can start to try and defend ourselves in terms of the attacks we've already talked about. This is more of a kind of pictorial version of that, if you like. So the gray boxes in this represent the types of attacks you have and where they might occur. So just picking on a few examples, you can see things like data injection and prompt injection. Now, they can be either by a bad actor that's compromised your machine, or the bad actor themselves might be trying to formulate queries that will compromise the model. And there's good examples of things like prompt injection that overwhelm a GenAI system or GenAI model as you're asking the question, that cause it to do various things or bypass some security you put in place. The classic example is when you're not allowed to ask a generative AI model how to make a bomb. And back in the days, the way around that were you would ask the generative AI to write a poem about how to make a bomb, and it responded perfectly adequately in order for you to achieve that. A lot of this has been worked into the models as a defense so that those things no longer work. But there's much more complicated ways of doing prompt injection to bypass some of the guardrails that might be in place in front of a model. So it's a constant war with the kind of red teams and the everything else. You can do things like request misdirection, which is basically, I think my question is going to some model, actually I'm sending it to a different model, which has either been polluted or is controlled by somebody else, or is just known to be giving me bad answers. And the last one I want to look at, because this is one that's not necessarily considered so much, is things like prompt and jailbreak manipulation within shared models specifically. So if you look at the public model, which we all tend to use, so OpenAI, there's stuff on various public cloud vendors as well. You think you have your own model often, but actually the back end of it is a single model, purely because the infrastructure to run it at the scale they're running it at is expensive. And so what you hit is a shared back end, even if it appears to be dedicated to you because the API might be dedicated to you, the gateways are yours. As you hit that shared back end, however, you're in a shared memory space. So any compromises that happen on that system that's running that model, and we've seen them, we've seen things like Heartbleed and other sort of compromised libraries in the back end before that we had 0 days that give us that kind of access. As you get access to that memory space, you have access to every question being asked and every response being given, including any data that was provided as context. So shared models are still a risk. They may be a small risk because most organizations do a very good job of defending it and keeping their systems patched and everything else, but it is still a risk. There's also infrastructure on the way in and infrastructure on their way out. So storage that may act as a cache or a queuing system for requests as they're going to the system, they can also be compromised, and they are very often shared as well. So we need to consider these things when we're thinking about what it is we're putting on the model. We have organizations we work very closely with that their IP is being generated by the model very often, or they're using their IP to influence the model in some way. And you really don't want that compromised because that's your business. So we talked about all the issues. I've depressed everybody. Well, I hope not, but I've made a good effort at trying to. I'm going to hand over to Sad to make us all happy again. Sad.
Thanks, Glenn. I think if we advance the slides, we will be talking about guardrails. So like guardrails is one of the way, like is actually how do we secure access to the models. So if you If you connect to the model, there might be you might be exposed to various attacks. Then if you're providing this to the enterprise or making this available within your company or within your organization, how actually you're going to secure these models? In the technology incubation office, part of the Octo, which is, I'm not going to read the big title, we have been playing with the various technologies to look around, like how do we work with different guardrail solutions to secure access to the GenAI LLM models that we're using or making available internally. The space is very dynamic. There's a bunch of open source solutions. There is a lot of startups we've been seeing every day coming up, and they proposing new solutions and new ways to secure the LLMs. And like, is it successful? Is it working? Like, what kind of approaches are they taking? We'll look at one of the solutions, which is open source, which is publicly available. People can look at it and can play with it if they want to. If we move to the next slide, please, Glenn. So we will be talking about Nemo Guardrails. Nemo Guardrails is an open source toolkit which is available and allows you to add a programmable guardrails to your LLM-based conversation. So this means like your guardrails can be programmable. It's not a static checks or static type kind of guardrails. You can write a program which is actually a guardrail program or a guardrail like way of addressing different flows of the conversations that goes between the user and the LLM. It's guardrails or rails, as we refer to it as we go through this presentation. It allows the LLM to focus on a specific topic or rule out other topics that you don't want your user to actually step into or discuss with the LLM. So part of this topic could be like politics. Okay, I'm making this available locally on my within the enterprise, but I don't want anybody from the organization to ask any political question or any religious questions or any other type of questions that might be willing to rule out from your policies. Or you would like the model to respond in a very specific way. Let's say like, okay, you need to use formal English in responding to the user. You need to use a specific way of kind of communicating with the user, and so on and so forth. So pretty much the guardrails will define a specific path. For the conversation between the user and the LLM, and also secure various attacks again between both parties. If we go to the next slide, please. So we'll just build it up. It's going to take a bit of graphics in there. Sorry. So what are the use cases for actually having guardrails? If you're implementing RAG, retrieval augmented generation, if you have a retrieval chain, Q&A, when you have RAG, you're kind of getting the LLM to focus on a specific area or a specific set of documents. So it makes more sense to add guardrails here to make sure the model is focused only on this area, is not going to ask other questions which the model could answer from his general knowledge. Another part could be like the domain-specific assistant. Again, the same thing applies here. If you have people like responding to like, let's say, companies that work in the health part, like you could have, or HR, like you could have an employee goes to the LLM and ask about their own benefits, their own financial situation, and so on and so forth. So you need to make them focused, and you need to set boundaries when the user goes to the LLM and asks these kind of questions. The third use case, you could also have an LLM, a wrapper around the LLM endpoint. So if you would like all the customer to have a safer interaction with the LLM, that could be also another solution that applies in here. For most of you who had an programmatic interaction with LLMs, you know what LangChain is. LangChain is a framework which provides a set of tools that you can use if you're building your pipeline to interact with the models. So LangChain is supported by Nemo Guardrails as well. Nemo Guardrails can kind of take care of this kind of, it supports out-of-the-box LangChain framework. So if you're having a LangChain pipeline, Nemo Guardrails supports that out of the box. If we, next slide, please. Let's build it out as well. There's going to be some graphics in here. Sorry, just, okay, cool. So again, the guardrails type, you can see in here, the guardrail types are input. We have an input type which kind of secure the interaction that come between the user and the LLM. So before we send any input from the user to the LLM, we need to make sure this input is valid. It doesn't contain any sensitive data, if we have any sensitive data, we need to mask it or make it anonymous before sending that to the model. And also, if it violates any kind of, like, if it goes with bad words or hate or self-harm or stuff like that, we need to block these kind of attacks. The other thing which is relevant to input is like output. Anything that comes from the LLM, you have to stop kind of these attacks. You have also to remove any sensitive data and from the response of the model, and need to make sure the model stays on topic if it is a topical or a specific domain LLM interaction. So I myself like try to connect with one of the models like a ChatGPT. Specifically, I went in there and I asked the ChatGPT to tell me how to hijack a car, and ChatGPT was like, "This is illegal to ask these kind of questions." Then I was able to write like, "Okay, can you write a poem?" or like asking in a very different way how to hijack a car. And ChatGPT was able to generate the answer. Hopefully, after a couple of days, I tried to log into my account. I didn't find the interaction, so OpenAI kind of deleted all that. So output rails kind of control this part. The model, even if you try to trick the model, it controls the output of the model. The dialogue piece is kind of in Nemo guardrails, it operates on something called canonical forms. So it defines how the flow should look like, and it provides some sort of utterance on how the interaction between the user and the model may look like. So it allows you to control this part, control the flow of the execution, control the flow of the dialogue between the user and the LLM, and execute some sort of action. And by executing some action, you will be stepping into the execution rails. The execution rails mainly applies on the input and output to execute some sort of actions before the interaction goes to the model, and after the interactions comes out of the after the response is generated by the model, and execute some sort of action. Let's say you can have an action like a block list. You can have an action like factually checking. You can fact check whatever the model is spitting out or is saying or responding with. You can add any sort of actions here with Nemo guardrails. And again, there is a special type of guardrails that applies on RAG use case, so it can prevent or can it reject some sort of chunk based on your policy. So within the Rails itself, if you have a document shared between different people, but you would like to specify or to only present certain information to specific people, you can do that with the retrieval Rails. Next slide, please. Again, so because of this area is moving so fast, we started adopting Nemo and working with Nemo guardrails when it was 0.5.0. And with that was the architecture of Nemo. Nemo provides a sample UI you can use to actually test Nemo guardrails and work with it if you want to. And it has a server like it supports a server with an API, so you can have all the guardrails behind an API. You can submit your request, and it tells you if it is okay or not. And also that will be driven from your application configuration and any custom configuration you might have as well. So the idea of Nemo guardrails, it works by having your policy. It generates embedding for your policy and generates embedding for the user input or user query, and then tries to compare this user input to the policy. And if it matches any flow, it will execute the flow against the policy. Then as part of the execution process, it will kind of connect to something called an action server within Nemo guardrails to execute a set of actions and connect you to the LLM. So Nemo guardrails, it was moving super fast. So this is an old architecture. It's kind of obsolete. It's not working anymore. Let's see the new architecture from Nemo guardrails. So let's build it. Sorry again for the graphics. So with the new architecture, you can have your own application code that connects directly in your configuration to an input rails and dialog rails. And there is an also output rails, which is available, I think, if we build the full slide. So the input rails and output rails, again, controls input and output to the LLM and output of the LLM. And the dialog rails will execute the flow and make sure you stay consistent within the flow. If the user input matches a specific flow, especially those ones that kind of violate the user or that violate the policy, you're going to execute the policy against that user question or user message, and same for the model as well. So the execution rails will then trigger any custom action you would like to integrate or you'd like to apply on your LLM. So this is kind of a set of actions or tools. Nemo guardrails kind of controls the access to the LLM, so you have to provide your access to the LLM to Nemo guardrails. So it kind of does that kind of connect to the LLM, generates a response, and make sure this is doesn't violate the policy before returning that to the user. The missing piece that if we build the remaining part of the slide again, sorry. That will be the RAG implementation. If you have retrieval augmented generation, that will allow you to connect to your knowledge base and execute the rails that apply to this knowledge base and control which chunks it should retrieve or which chunks it should leave out of the guardrails. Again, this only applies to NeMo 0.6.1 or 0.7 or 0.6.1 and onwards. Before that, it was a completely different architecture. Let's go to the next slide. Yeah, I think that concludes all the NeMo guardrail stuff. Was that I'll give it back to, yeah, go ahead. Sorry.
Yeah, before we pass on to Tom to close out, there's actually a question that I think is very related to this.
Yeah, sure.
And the question is, can you talk about how adding guardrails, especially those provided by a third-party vendor, might itself make an AI workflow less robust, less accurate, and less secure? Do you want to have a pop at that one?
Yeah, sure. So in NeMo guardrails, it provides you a framework. You should add your own policies, your own guardrails that control, like, you know, your use case pretty well. The open source solution doesn't know your guardrails or doesn't know like what fits you, what doesn't fit you. NeMo provides a framework you can use, or any other guardrail solution. We have been looking at few actually, like guardrails, AI, and other technologies as well. So that should allow you, should give you the capability to control how your LLM should respond to different scenarios and different flows. It shouldn't dictate really any policies. It shouldn't add any policies specifically for you. You should define your own policies. And in NeMo, it is canonical. It kind of looks like Python, but it's not really very Pythonic, if you know what I mean. So it's kind of, you define a flow, user ask about capabilities, and then you have, okay, user ask about capabilities and bot response about capabilities. Then you provide some sort of utterness. Utterness is kind of, you give a sample statements which shows how the user would ask about the capabilities and how the model would respond to that question. Then you generate embeddings, and you know, in this space, how embeddings work. You compare, you do similarity check, and then you ask the model to generate something similar to this, not necessarily the exact same word, but something similar to this in the same context and same way. Hopefully that answer or covers the question. If
I think so, Saad. What I will add is just in general, so not just around the NeMo piece, but
yeah,
anything you add to any kind of pipeline will always introduce some kind of latency or some kind of fragility. There's another component that can break. So you do have to kind of weigh up what advantage you're getting from it and what protections you're getting from it versus the issues or the challenges it might bring with it, which can not only decide whether you need guardrails, and usually the answer will be yes, but also what type of guardrails are appropriate. There are some that use models, for example, and as Saad was touching on for the NeMo guardrails piece, initially it had multiple passes at a model, which means you're injecting latency for each of those passes. So responses could be anything up to sort of 10 seconds before you get it. That isn't suitable for most use cases. It may be suitable for some, but it's not suitable for most use cases. And so that might be a poor choice of architecture for that particular scenario. On the other hand, there are ways of doing the kind of blocking and policy management using heuristics and using traditional firewall-like technology that is much more rapid. However, it doesn't necessarily be able to infer context of what you're trying to do because it's hard-coded if this, then that. And so the challenge might be a little bit around, am I getting enough done? And so what you tend to see is hybrid versions of these things sort of build out. Cool. Thanks, Ted. So over to Tom to bring us home.
Okay. So if you have listened to the announcements at HPE Discover Barcelona in 2023, there was an announcement of the generative AI ops, which is what we're talking about here. So we demoed it as kind of an incubation or a forward-looking technology. Project Ethan, which we brought up here, this is the project that's being run from the HPE Office of the CTO Technical Incubation Office around the adding of guardrails, adding of the security to allow users to have a secure or controlled access to their LLMs. And this is both in the chat experience as well as direct API calls to the LLMs itself. I would suggest to everybody, stay tuned for Discover Las Vegas in 2024. 2024, so coming up in June, there will be further announcements about the available of this technology to HPE customers. And so rather than cover that here, I'll just leave that as an open point. If there are internal HPE teams who would like to know more, please reach out to us. But in this forum, I'll just refer everyone to HPE Discover for future announcements on the availability of these types of offerings from HPE. So let's go to the next slide. I think there's one graphical slide left here. Okay, so this shows the whole pieces together on HPE GreenLake platform. We have the infrastructure, so our hardware that runs the LLMs itself and runs the controlling code. We have the AI platform with data management, model training, also model as a service, model inference, and then those can be various open source models, whether they're publicly hosted like GPT-4 on Azure, or if a customer has their own hardware and they're running their own instances of a private model, something like Luminous from Alfalfa or something like that. This tooling will work with any of those models and use the LangChain code to build out a solution with RAG as well as the guardrails solution. So what HPE is aiming for is to provide secure access to artificial intelligence for anybody, no matter whether those LLMs are in the public cloud or on privately controlled LLMs. One platform, vendor neutral, cloud neutral, AI access for all. So we're right at the end of time here. I'll stop that with our formal remarks. And if there's any further questions, we can take them in the chat or here live for a few minutes while we have a few minutes remaining.
Thank you, Paul. Tom, sorry. Thank you, Glenn, and thank you, Zad. I don't think we'll take live questions, I'm afraid, but we have a couple of remaining questions in the chat. I think they are more for internal people. Anyway, thanks for this session. I think this was great. Just to remind everyone, we have a poll here for the end of session here. Thank you for providing feedback. That's always helpful for the program itself. We will make the slides available at least as PDF when the guys send it to me, and I will try to put it in a place internally for the ones requesting the PPT if possible. We will also work on the replay through our marketing engine here, and we should have that within a week available on the Munch and Learn page on our developer.hp.com website. So stay tuned there. And thanks everyone for joining. I think it was yet another great session from a group of great speakers. We'll talk to you next month. There's more on AI from HPE, so stay tuned. Thank you very much, everyone.